Hi, Kendall.
Hi.
How are you doing tonight?
I'm okay. How are you?
Oh, I'm fine. I got a lot of geometry students struggling with this stuff.
Yeah.
All right. Shall we start on one?
Yeah.
Okay. What we're looking at here is a bunch of similar triangles. And we know that if we can figure out which triangles are similar, we can relate corresponding parts. Okay? We also know that this side to that side should be the same as 36 is to A. Right? In other words, because these lines are parallel, these relationships between these sides are all the same. In other words, I can see that 24 is to 18 as 36 is to A.
Okay.
Which makes this is 4 is to 3. So I've got 4A equals 108. A equals 27. Okay. And now, just for the heck of it, let's make sure that this triangle and this triangle, we know they're similar, but did we do it right? In other words, 18 should be to A plus 18, as 24 is to that. So I've got is 18 to 27, which is what A is, the same as 24 is to 36. And yes, they're both 2/3.
Okay.
Let me just say something about this that might be confusing. I find that this principle confuses a lot of people. I have two similar triangles. The way you normally do this is you take the same corresponding side of that triangle and you make it 10 is to 5 as 12 is to 6 as 14 is to 7, right? That's the way we usually look at the ratios when we have similar triangles. But it turns out that there's actually another way to do it. I can look at the ratio within that triangle alone. 5 is to 7 as 10 is to 14. In other words, this left side is to the base as this left side is to its base. So that can confuse a lot of people because it just makes it look like you can do any old ratios you want. And you can for the most part. But understanding that these ratios work both ways, within the triangle and between the two triangles. So when we have this problem here, the easiest way to address this is not really using similar triangles. I mean, I could look at this triangle right here. I'm going to have to use similar triangles at some point. And in fact, to find out what D is, I need to use similar triangles. Here's my two triangles. And I now have all the measurements of them. Let me draw it for you. Sometimes the hardest part of these problems is just picturing it. There's my one triangle. It's 36, 24, 27, and 18, right? There's D. Oh, excuse me, yeah. I don't want D in there. This is 40. And I'm going to draw my little triangle apart just because it's easier to see that way. Those are similar, and I know 24, 18, and this is D. So what ratio can I come up with? I have all three sides of this triangle. I only have two sides of this triangle, but I know they're similar. So what's my ratio?
Would it be 18 over 24 equals D to 40?
Correct. Yeah. Although, yeah, no, that's correct, totally. Little to big, 18 to 24. No, excuse me. You mix them up. In other words, when you compared 18 to 24, you were comparing two sides of the same triangle.
Okay.
Now you don't want to make that equal to the base of this triangle compared to the base of that triangle. That's comparing two different parts.
Okay.
So let's compare this side to this side. Those are the corresponding sides, right? Well, that's 18 to 45. Comparing this side to this side has to be the same ratio as this base is to this base. And that's D is to 40. Okay, so this is a little tricky. This is where you can definitely get confused by comparing the wrong things. In other words, I can't create a ratio from one triangle only and then compare it to a ratio of one side of this triangle to the other side of this triangle.
Okay.
Now, how do I solve that?
You cross multiply.
No. That's what everybody does. Notice what cross multiplication is. Cross multiplication is multiplying both sides by 40 and multiplying both sides by 45. Okay? So I would get this. But then I got to divide both sides by 45, right? Well, I just multiplied both sides by 45 and divided both sides by 45. That was a wasted effort. Why don't I just take and multiply both sides by 40 only? Now you end up with 18 over 45 times 40. And the other side is D, which is what we're solving for. One step only. In other words, you don't always have to cross multiply just because you can.
Okay.
Sometimes it's not the best way to go. If the variable is in the denominator, then you have to cross multiply. Because I wouldn't be able to solve for D with one step. But if the variable is in one of the numerators, I only need one step. I need to get rid of this 40. And I can get rid of that 40 by multiplying both sides by 40. Now, this becomes 8 over 9. That becomes 2, so D is 16. You want to fill it in as we go along?
Yeah.
Basically, what I'm going to do is go right to left until we get all the letters.
Okay.
Okay? Now, I have established a relationship between sides here. I know that this is a 4 to 3 relationship between this and that within that triangle.
Okay.
That means this has to be 4 to 3. That's how I got 27. Notice this is not 4 to 3. That's 40 to 16. So you can't just establish a relationship and then use it everywhere. It doesn't work.
Okay.
However, the relationship between 45 and B has to be the same as 24 and 18. So give me an equation that solves for B. Starting with 24 is to 18
Yeah.
equals what?
As B is to 45.
Correct. In other words, we know that every one of these has this 4 to 3 relationship. This is 4 times 4/3 that, this is 4/3 that, this is 4/3 that.
Okay.
So what does B end up being? And again, we don't need to cross multiply. We just need to multiply both sides by 45. Now this becomes 4/3, and now that becomes 15 times 4. So B is 60.
Yeah.
What's C? Let's skip over E for a moment and figure out what C is. Give me the ratio. Always, in other words, don't try to solve it all in one step. Try to write a ratio.
Okay. 18 is to 24 as...
I would let's keep going big as to little.
Okay.
You can switch it up. There's nothing wrong with switching it up. The problem with switching it up is you might not switch up over here. We've been going big to little the whole way. So let's not change that. That's equal to 4/3, and what is that ratio supposed to be equal to relative to C? Go big to little.
30 over C.
Now, to solve that takes 2 steps. I do have to cross multiply because there's no single step that will let me solve for C. So I do cross multiply and then I divide by 4. So C equals
22.5. And it says round decimals to the nearest 10th place.
22.5. 0.5 is the 10th place. To the nearest 10th decimal? It said 10th.
Yeah.
10th, right? Yeah.
Mm-hmm.
Yeah, so it's rounded already. In other words, it's 22.50000. So just 22.5. So that's C. So we've solved for A, B, C, and D. Now to solve for E, we have to use the same kind of analysis as we did before. Let's compare this triangle with this big triangle.
Okay.
Okay. Well, we want to compare 18 to what?
24.
We want to compare this side of the little triangle to the same side of the big triangle.
Okay.
What's the big side of that triangle? What number is that? It's 45 plus 27 plus 18. That's 90. Okay. In other words, it's important. I'm going to draw it again separately. There's my big triangle. That's E. Okay. What's this length right there?
45.
No, 45 is that length right there. The whole length of that side of that triangle is 45 plus A plus 18.
Oh, that would be 90.
Okay. So that's 90. And now let's look at this little triangle here. I'm going to draw it separately. What ratio compares corresponding sides? What was D? What was our measurement of D?
16.
So you're comparing this similar triangle to this similar triangle, trying to solve for E. What ratio is going to work?
90/18.
Good. Go big to little because that's going to make it easier to solve for E rather than big. Notice Y. What's the rest of it?
16/E.
No, you went the wrong way. You went little to big. You can't go big to little and then go little to big.
Okay.
Just be consistent. I don't care if you go little to big or big to little, but just keep with it. Don't switch it up. So what's the ratio regarding E?
E/16.
Right. That's big over little. And notice the advantage we did in doing 90:18 is it leaves E in the numerator, makes it easier to solve. I could have just as easily said 18:90. 18:90 as 16:E, but now my E is in the denominator and I got to go through the whole cross multiplication and then dividing by 18 routine. So it's actually better to do 90:18. Big is to little, as big is to little. 90:18 is a 5 times. So E is 5 times 16. Oops, hold on a second. 90 is, yeah, that's 5 times 18. So 5 times 16 is 80. And now we might realize that, well, 90:80 is 18:16. That's also true. In other words, I've got that situation here where I can relate corresponding sides to each other or sides within the triangle to each other. 18:16 as 90:80 is a true statement. Okay? Also true that 90:18 is 80:16.
Okay.
Okay, so there's only one last thing to solve for, right?
Yeah. Do you mind if we went over to the back side of this page?
I feel like since we've solved for all of these, you can probably figure out how to solve for F.
Yeah.
You got two similar triangles, you got the big triangle, and you got this little triangle that you know all the dimensions of that little triangle.
Yeah.
Okay. Other page?
Yeah, the next page, it's the back side of this one.
Is that this one?
Yeah.
Okay. You tell me how long you want to go. We can go a half hour, we can go an hour, we can go 45 minutes, we can go 40 minutes. It doesn't matter to me.
Okay,
I'll charge you whatever you go.
Okay.
You don't have to stop on the half hour or go a full hour if you don't want.
Okay, I think I want to go an hour, but in like about 10 minutes, my computer is going to update itself, so I'll have to switch over to a different computer, basically. Conveniently.
Okay, what are we looking at here? What ratio applies in problem 5?
Would it be x over 55 equals 22/14?
First of all, are these similar triangles? Does it say there?
Yeah. No.
Just solve for the unknown variable.
Yeah.
And we've got the same side,
Okay.
got the same angle, but I don't see anything else the same. However, the fact that this angle is being bisected means that the ratio of 22 to 14 is the same as the ratio to 55 to x.
Okay.
Only because that angle is being bisected.
Mm-hmm.
Yeah. I'm not quite sure how we prove those are similar. I don't see how they're similar. Oh, I guess because of this bisection here, we know that ratio has to be. All right, let's look at 6.
Okay.
We got two similar triangles, you see them?
Yeah.
Not this and this, but this and the big one. That's what's similar. Okay?
Okay.
So what ratio can I come up with? In other words, a numerical ratio that expresses the linear ratio of those two triangles. Where do we have nothing but numbers? The two bases, the 30 and the 80.
Yeah.
So let's always compare triangles to each other, not within. And it's not wrong to do within, but if we're going to compare triangles to each other, there's the big triangle. This is 30. This is 20 plus x, right?
Mm-hmm.
That side. Now let's draw the small triangle. That's x, that's 18. That's all we need to solve for x. Why? Because I have this fundamental relationship between this part of the triangle and this part of the triangle. Between triangles, I have found a relationship. 30 to 18. So 30 is to 18 as what?
30 is 18 as 20 plus x over would it be?
In other words, here's our triangle. This side is similar to this side. That side is similar to that side. I'm using congruency only because I don't know how to write similarity marking. Okay? So that's our situation. We have all three of those sides are congruent to one another. So 30 is to 18 has to be the same as this side is to this side.
Okay.
Okay? This side is 20 plus x. This side is x. So now I just have to solve this. It's not that hard to solve. There's only one variable, x. Cross multiply. We have 30x equals 360 plus 18x. Move the 18x over. We got 12x equals 360. X equals 30.
Okay.
Okay.
That makes a little bit more sense now. Mm-hmm.
Yeah, I think your entire source of confusion was the ability to do ratios within a triangle and compare that with ratios within another triangle.
Yeah.
Or you can do the same side of one triangle versus the same side of another triangle and maintain that ratio. I like to do the second kind. It's less chance of confusion. If
Yeah.
I'm always comparing this side with that side, I'm not going to
Okay.
compare this 30 with 20 plus x. I could. In other words, I could say, compare the 30, the base of this triangle, with its own side. This is legitimate. And compare the base of that triangle with its own side. That will give me the same answer.
Okay.
And I can do it. But it creates confusion because the only thing you want to make sure you don't do is mix them up. I don't want to compare 30 to 20 plus x and then compare x to 20 plus x.
Yeah.
That would be mixing up the two methods.
I'm going to have to switch computers.
Okay, I'll just hang around. In other words, you go ahead and sign out a GoToMeeting on this one.
Okay, should I use the
Sign
same
back
ID?
in with the same meeting ID number, yeah.
Okay, I'll be back in like a minute.
Hi, Kendall.
Hi, sorry about that.
It's all right. That wasn't bad. It's not nearly as bad as having to reboot.
Yeah, my computer always decides to update at the convenient times.
Okay, number 7. They tell us that one triangle is similar to another.
Okay.
Which angles are the same? Let me draw this. Just a second. And this is the difficulty with similarity, is when they orient it in a weird way.
Yeah.
In other words, it's difficult. They tell us that they're similar, But which angles? Similarity means three same angles. Which angles are equal?
Would the angles A be equal?
No, angle A is not really an angle of either triangle. Angle CAD, maybe. But you can't just call that angle A because angle A is the distance, that's the whole angle.
Okay.
Okay? So if we're going to talk about triangles, the way to tell which angles are equal are which side is equal.
Okay.
18 is equal to itself, right? In other
Yeah.
words, AC is part of both triangles.
Mhm.
So if these triangles are similar, the angle opposite, the side that's the same, has to be equal. Hold on a moment.
Okay.
Think about that logic for a second. Not true. Well, this is a 9, 12, 18 triangle.
Mhm.
Okay, I guess we have to go up to the terminology. In other words, if we want to know, since they've defined it as ABC is similar to CAD, that means angle A of this triangle, this angle right here,
Yeah.
is the same as angle C, this angle right here.
Okay.
Sure doesn't look like it though.
Yeah.
That's obtuse, that's acute. So much for that, using that method. Well, the other method is we can look at obtuse. That obtuse angle right there, the only obtuse angle over here is that one.
Mhm.
So I can say that angle ACB is equal to angle D. Right?
Okay. Okay.
Only because they're both obtuse.
Yeah.
Those are the only two that can be equal. Now, since D is between this angle and C is between this angle and this angle,
Okay.
notice what's the similarity ratio going to be? If I take this triangle right here,
Okay.
move it to a position so that angle ACB, this one, sits on top of this one,
Mhm.
what's going to be the corresponding side to 18?
Would it?
Just take this triangle and rotate it a little bit and move it so that that angle sits on top of that angle.
So would it?
So it'd be 18 would be to 9, right?
Yeah.
In other words, this side, this corresponding side is this side.
Okay.
And the only reason I can see it is because I know that that angle is matching with this angle. And so if I brought that whole thing down and set it on top of each other, this side of 18 would correspond with that side of 9. So my similarity ratio is 18 to 9.
Okay.
Equals what?
Would it be x to 18?
No. X, this side, will be on top of this side.
So
X is to 12. So x has to be 24.
Okay.
And I can use that same similarity ratio, 18 is to 9, for the other side. Which is the corresponding side for y? When I do what I suggested, which is to move this triangle so that the C is sitting on top of the D.
Okay.
So 18 is to 9 as y is to what?
As y is to 12?
18.
Mm,
This side becomes this side.
okay, I
Right?
see.
In other words, if I take this triangle, rotate it a little bit, and stick this angle on top of this one, then side AC becomes side AD, side AB becomes AC, and side BC becomes CD. So 18 is to 9 as y is to 18.
Okay.
Makes y 36. So this side's 36. This side is 24.
Okay.
Now I can see that this triangle is clearly similar to that triangle because all of my corresponding sides ratio is the same. 9 is to 18, as 12 is to 24, as 18 is to 36. And all my interrelationships are the same. 36 is to 24, as 18 is to 12.
Okay.
But you don't need to do it both ways. In other words, one way is sufficient. The only difficulty with this problem is figuring out which angle is the corresponding angle over here. It's not that clear how to do it.
Yeah.
Luckily, they gave us they didn't give us three identical angles or close to identical. It would have been tough to do, to figure out which angle was the same. But in this case, that's the only obtuse one, so this has to match this one. Both of these are acute. And to get this one to match that one, I have to basically rotate that a little bit and move it down. And then I will have them oriented properly. And once they're oriented in the same way, then it's easy to figure out what the corresponding sides are.
Okay.
In other words, the secret here is to draw that triangle separately, and then take this triangle and put it on top of that one in the same orientation. And I know it's like this because I know this angle has to be this angle. So you see what I'm doing here? And
Yeah.
the small one is 9, 12, 18. And the only thing I know about the big one is this side right here is 18 after I move it. So the ratio is 18 to 9.
Okay.
All right. Let's look at another one. Kind of disappointed in their terminology here. I thought that you were supposed to be able to tell the equivalent angles by that.
Yeah, the way they have some of these triangles and the position makes it a lot more confusing.
Oh, I see what's going on. Oh, no, I don't. Huh. Yeah, no, their terminology here. In other words, I think you're supposed to be able to say that angle A is equal to angle C, and angle B is equal to angle A, and angle C is equal to D.
Yeah.
But not the way they've drawn it and labeled it. That's not the case. In other words, we have angle C being equal to angle D. Well, of course, that's what that says. C is equal to D. So maybe they did it right. A, B, C, there's C, is similar to C, A, D. There's D. So yeah, C is equal to D based on the terminology.
Yeah.
All right, let's look at 8. Again, we have similar triangles, but this time it looks like, can we tell which angles are the same?
Yeah.
Well, according to the terminology, A is equal to E.
Yeah.
And that's correct, isn't it? Isn't that what it's supposed to be?
Yeah.
Okay. Well, if A is equal to E, and B is clearly equal to D,
Mhm.
so C, which is actually this angle, is equal to this angle, which is also C.
Okay.
Okay? In other words, if I separate these two, this would be ABC, and this angle would be C. If I separate this triangle, it's going to be EDC, and that angle is going to be C also. Okay? So now we have our similar parts. What is the ratio between the triangles? Not within the triangles, but between the triangles. In other words, we've figured out which angles are the same.
Yeah.
Which sides are the same? Which two sides that we have measurements on are the same corresponding side of both of these triangles?
AB is equal to ED.
Correct. So the ratio is 30 to 12. Okay. And what's the right side of that?
X to 8.
Yep. Bigger to smaller. Okay. Let's go to 9. And here's the same principle as we had in 5. Notice that 5 is not similar triangles.
Okay.
But there's a theorem in geometry that says is that if you take a triangle and you bisect it, the ratio of this side to that side is going to be the same as the ratio of this side to that side. So we're going to do that same thing in 9, because notice that's what they've done in 9. They've taken a triangle, bisected that angle. So I can say x is to y as what?
X is to y as...
That's a tough one.
So 44 is to 56?
Yeah, unfortunately that doesn't allow us to solve it, does it?
No.
It actually does. In other words, x, small is to the large. I can tell y is bigger than x.
Okay.
Has to be 44 is to 56. But that doesn't let me solve it. There's two variables. I need another equation involving x and y. What other equation can you give me that is involving x and y?
You could do 50 plus y.
X plus
Okay.
y equals 52.
Okay.
Not a ratio. We don't need a ratio. We just need a second equation. It's
Yeah.
totally independent. Okay? And now we can solve this system of equations. If I want to solve for x, then I'm going to let y equal 52 minus x, and then I'm going to substitute that for that y right there. So I'm going to have x over 52 minus x equals 44 over 56. Now I have one variable only. I can solve it easily.
Okay.
Once I've solved for x, well, I know y is equal to 52 minus x. So I can solve for y.
Okay.
Okay? Now this a little tricky because this is not just about ratios. You have to actually come in with a second equation that's not a ratio equation.
Yeah. Do you think we could, so there's a third page, and it's 4, 5, 6, 7, 8, and 9. Could we take a look at those?
Is this the third page?
Yes.
Yeah. Okay. Okay, here we don't really know. These are similar. Use similar triangles. Okay, so they are telling us that all these triangles are similar.
Yeah.
No, they don't make that line parallel to that line. We do know it's parallel if they're telling us that that triangle is similar to the big triangle in 5.
Mm-hmm.
That ensures that that's parallel to that, because if that was parallel to that, we'd be able to tell they're similar.
Yeah.
Okay, so let's compare triangle to triangle.
Okay.
And again, I'm going to do this just for clarification because it's easier to do these when they're separated. There's the two triangles.
Okay.
X, that's 16. This is what?
24. And then,
Plus X.
yeah.
What's this side over here?
22.
No? 22 is the measurement of that trapezoid. That side of a trapezoid.
Oh, it would be 38.
Correct.
Okay.
Okay. Now I've got only one variable and I got all kinds of relationships. What's the relationship ratio equal to? Triangle to triangle, not triangle within triangle.
So,
What's the one not involving variables that you can actually put a number on immediately?
16.
Go big to little.
So 38 to 16
Equals what?
equals 24 plus x over x.
Right.
Okay.
In other words, is all I've done is that side of the triangle is the same as that side of the triangle. Not the same as, but similar.
Yeah.
Okay, so whatever ratio exists between those corresponding parts of similar triangles has to be the same for every other side. In other words, this side is to that side as 38 is to 16.
Okay.
We can't figure it out because we don't have measurements on either of those. But we can solve for x because this equation only has one variable. Cross multiply and solve for x.
Okay.
Do you know how to do that, or should we go through that?
I know how to do that.
Okay, good. Number 6. Now, again, 6 is a little strange because we certainly know this angle is equal to this angle.
Yeah.
But is it this angle equal to that angle, or is it this angle equal to this angle? We kind of have to look at the sides relationship.
Yeah.
This, in other words, in this case, because I can't tell right away which angle is equal to one another, let's do this one a little different. In other words, what we can tell is this ratio 15 to 12, just within this triangle, not comparing the two. Just 15 to 12, okay?
Okay.
What relationship between two sides is that same relationship? Is it 18 to 16? Is it 20 to 18?
Wouldn't it be 20 to 16?
Now we have found our similar sides.
Okay.
In other words, now we know that this side is to this side. So we have a 20 to 15 ratio between the similar triangles. In other words, the only reason I did that was to tell me that the 15 is the corresponding side of the 20.
Okay.
And the 12 is the corresponding side of the 16. Okay? So, what is the relationship between the big triangle and the little triangle? What is the scale factor?
So,
Pick a side over here and find its corresponding side in this triangle.
okay.
What is it? So it's 20 is to what?
20 is to 15?
Yeah, we just proved that those were the corresponding sides. It's not 20 is to 12. This side is not the corresponding side with that side. This side is the corresponding side with this side.
Okay.
In other words, the ratio that makes these two things the same is 20 is to 15 as 16 is to 12.
Okay.
Both of those are 4 to 3 ratios. And more importantly, solving for x, what do I want on the right side?
X.
No? Always go big to little. If you start big to little, make sure you stay big to little.
Okay, so 18 over x.
There you go.
Okay.
Notice that now I have compared the corresponding side of one triangle to another triangle equals this corresponding side to this corresponding side.
Could you do 16 over 12 as well?
Yeah, because those are also corresponding sides. That gives you the same ratio. That's a 4 to 3 ratio, and the same as 20 is to 15.
Okay.
That's how I figured out that these were corresponding sides and not, in other words, notice that 20 is to 12 is not the same as 16 is to 15. So I know that these are not corresponding sides. They don't have the same ratio.
Okay.
In order to figure out which are the corresponding sides, I have to find sides that have the same ratio.
Okay.
Okay? Okay, let's look at 7. The question with 7 is that which are the two similar triangles? I guess this one and this one. Not this one. Well, it could be this one and the big one. Or it could be all three. But at a minimum, this triangle is similar to that triangle. So if you wanted to orient them properly, rotate this 90 degrees counterclockwise. You know what I mean by that?
Um,
If
not
I
really.
take this, well, rotate it to the left. Counterclockwise is like that.
Okay.
If you rotate it to the left, this angle will fall on top of that angle, right?
Yeah.
And then you will have them oriented properly.
Okay.
So, notice that this hypotenuse will be with this hypotenuse. That's one
Yeah.
way. When you have similar triangles and they're right triangles, it's really easy to orient them because you know the hypotenuses are the corresponding sides. So I can
Okay.
say 34 is the blank. I don't have that measurement, so let's not use that one.
Okay.
But after I've rotated it, give me a relationship that we can see.
30 is to 16.
Correct. Beautiful. 30 is to 16 as what?
As
Hold on. Actually, if I'm going to compare these two triangles, it's not 30 is to 16. Remember, I want to compare corresponding sides.
okay.
It actually is 30 is to 16. In other words, once I rotate this and set it on top of this one, this side of 30 is going to be the same corresponding side as this side of 16, right?
Yeah.
Equals what? It's a little tricky.
Wouldn't it be 30 is to x because 30 is also
Make sure you go big to little. Oh,
so x to 30.
you see
So,
what x is to 30? In other words, once
yeah.
I rotate this over here, that side is the same corresponding side as that side. And this side is the same corresponding side as this side. So the ratio is 30 is to 16 as x is to 30. In other words, I always have to go big to little, corresponding sides, big to little.
Okay.
In this case, the 30 happens to be the corresponding side the same as x, but the 16 is the same corresponding side as the 30. When I rotate this triangle and stick this angle on top of this angle, the 16 is the vertical side, so is 30.
Okay.
I'm not sure I can read 8 enough to figure it out.
Okay. So
What dimensions do we have on this first triangle here? On 8.
So in the first triangle, you would have 36 for the shortest base, or shortest
Is
line.
that 36 there?
Yeah,
That's x,
yeah, and then there's no number for the,
and that's it, right?
yeah.
Well, this triangle here has only one obtuse angle. In this triangle here, where's the obtuse angle? You can probably see it, not me. The
Obtuse.
top one or the bottom one?
It's the top one.
That one there?
Yeah.
So I can say that angle is the same as that angle.
Yes.
Now that orients it for us,
Mm-hmm.
I believe. In other words, the only thing we have to do is to rotate this thing around until those two angles are on top of one another.
Yeah.
Or rotate it and flip. In other words, it has to be rotated and flipped. In other words, I can't just rotate it and put that angle over that angle, because I may still have it oriented backwards. The angles will still match up, but the sides might not.
Okay.
Well, what do I know about this side and that side? If this is the obtuse angle, then this side here we'll call y.
Okay.
Hold on, let me go back a second. That angle's equal to that. And x is the corresponding part to 16.
Yeah.
So 48 is the corresponding part to 36. There's no other choices. We couldn't solve the problem if that was not the solution. Okay? So I have big to little, 48 is to 36, as what?
X is to 116.
You just went little to big.
116 to X.
There. That's maintaining the big to little. We know this is the bigger triangle. And that's the corresponding side to that, because they're both opposite the obtuse angle. So that's one way to tell. If you can find the obtuse angle, then the side that's opposite it is the corresponding side on the other triangle.
Okay.
And this side here is corresponding to that side. Notice it goes side, side, angle. This one goes side, side, angle.
Yeah.
So just solve that and you'll have your answer. And the last one is 9 equilateral triangles. What is x? What's the definition of an equilateral triangle?
Equilateral, all lengths are the same.
What's x?
8.
That's all we need to know.
Okay.
Okay? They could even said isosceles. Now they couldn't have said isosceles. If they'd have said isosceles, this side might be 8. But when they say equilateral, all three sides have to be 8. And they didn't ask us anything about this triangle. This triangle was stuck there just to confuse us. You could erase this triangle completely. We don't need this triangle to solve for x, not when they tell us it's an equilateral triangle. Okay?
All
right, you good to go, Kendall?
I think so.
Okay. Just always remember to do your relationships either triangle to triangle or within the triangle compared to within the other triangle. You can do them both ways, just don't mix them up.
Okay.
Okay? I will talk to you next time. Good luck on your quiz tomorrow.
Alright, thank you.